So let me call this event H. That the company will win this bid, okay, or H, the large hotel, and the other bid to build a commercial office building in New York City. So let me call this C. So this company submitted two bids. The company believes it has a 40% chance of winning the hotel bid and 25% chance of winning the office building bid. So if we say that if we start by the hotel building the large hotel, building the large hotel, the company has, this is the hotel, okay, the company could win the bid and the probability is 0.4 because 40% chance of winning the hotel bid. Winning or not winning, okay, not winning would be 0.6. This is the first bid. Now, the company also believes that winning the hotel bid is independent of winning the office building bid. So I'd like to consider the second case now. The function wins the company office, building a commercial office in New York. There are two possibilities. Either the company will win. We can call this win H, not win H, or lose H, okay? And here win C, and not win C, or losing C, okay? And here win C, the commercial office, and not C. And now the probability that I need to find, what is the probability that the function will win C, given that she wins H, okay? He said they are independent of each other. So in this case, probability of WC given WH, just probability of WC because of independence. This is the definition of independence. So this probability, which is usually a conditional probability, it would be now equal to probability of C only because of independence. And probability that the company will win the commercial office is 25%. So this is 0.25. So probability that it will not win is 0.65 or 75, sorry. And the probability that she wins is 0.25. Either it's not important whether she loses or wins the hotel. The probability that it will win the commercial office is 0.25 and 0.75 not winning. So this is the meaning that H and C are independent. So they do not influence each other. Winning the hotel or losing does not influence winning the commercial office. It's always the same. So this is a tree diagram to illustrate the case here. What is the question? Part A says, what is the probability that the company will win both contracts? So probability of winning the commercial office and winning the hotel. Okay, building the hotel, building the commercial office. Well, how to find the probability of intersection? If they are independent, you just multiply winning C times winning H. So probability of winning C is 0.25. Probability of winning H is 0.4. Also, if you remember, we can find the probability of intersection by multiplying these two, the tree diagram. So the answer would be 0.25 times 0.4. The answer is 0.1. So this is the probability that the company will win both contracts. What is the probability that the company will win at least one contract? Winning at least one contract means winning H or winning C. So this is the sample space of this experiment. We have when C, when H. This is one possibility, winning both contracts, or winning. Let me start by H first because H is the first one. So I will write here H and here C, doesn't matter, okay? Or WH and losing the second one, winning the first one, losing the second one, or losing the first one and winning the second one, or losing both contracts. These are the four possibilities. So if he asks about what is the probability that the company will win at least one contract, so he's asking about the probability of these three. So you can add the probability of these three and you answer the question, or you can say this is 1 minus probability of NHNC, means losing both contracts. So probability that the company will win at least one contract is 1 minus probability of losing both contracts, because this is the only probability missing. So this is 1 minus probability of losing both contracts would be 0.75 times 0.6. So it's 1 minus 0.6 times 0.75, and this would be the probability of winning at least one contract. The answer is 0.55. What is the probability that the company will lose both contracts? Actually, this is the probability we found in part B. So this is the answer. This is the probability that the company will lose both contracts. So you can find the probability of each one of these. Okay, and this is, for example, 0.45, and this is 0.1. And you can find this one and this one by multiplying 0.4 times 0.75, 0.4 times 0.25. And the sum of the four probabilities would be 1. The last point in this section is Bayes theorem. And in the Bayes theorem, we usually start by E1 and E2, maybe more, maybe E1, E2, A3. So usually S, the sample space, is divided into 3 or 2 or 4, whatever, some number of events, but in a way such that they are mutually exclusive. There is no intersection between them, and their union would give you S. And then, so usually if you have a tree diagram, you do it like this. We have E1, E2, and E3. Okay. And now we have an event B. So this event B usually works here everywhere. Okay, part of it has a part from each of these events. So we have event B or B complement, not B. B or B complement. B or B complement. So this is the tree diagram for the Bayes theorem. Always we will have a tree diagram like this. And he will give me in the question, so given in the question, I will be given these probabilities. Probability of E1 and E2 and E3. So these probabilities would be given in the question. Also would be given in the question probability of B given E1. So this probability and this and this. Probability of B given E1, probability of B given E2, probability of B given E3. These three probabilities would be also given in the question. And then he will ask some other questions, okay, about the tree diagram, which we can answer from the tree diagram. So for example, he can ask about probability of B, okay? And to find probability of B, in fact, what would be probability of B? It would be this one, what is written below. All of this, the denominator, this is in fact equals probability of B. To find probability of B from the tree diagram, it's probability of E1 times probability of B given E1, which is this one, plus probability of E2 times probability of B given E2, which is this one. You multiply these two, plus probability of E3 times probability of B given E3, which is this one. So you can find probability of B from the tree diagram. And you can answer questions like this also. Probability of E1 given B. So E1 given B would be E1 intersection B, which is this one, over probability of B. Let us take an example. Here I have probability of E1 given, which is 0.35. Probability of E2 is given, which is 0.25. And probability of E3 is given, which is 0.4. And there is a probability B, an event B, and B complements. B and not B. B and not B. The probability given in the question, probability of B given E1, which is this one. B given E2, which is this one. B given E3, which is this one. You can find the others easily. 1 minus. So if this is 0.25, this would be 0.75. If this is 0.15, this would be 0.85. If this is 0.6, this is 0.4. And he can ask some questions now. What is the probability of E1 given B? So probability of E1 given B would be the probability of E1 intersection B, which is probability of E1. Let me write it, okay? Probability of E1 given B is probability of E1 intersection B. Let me write it like this for you to understand. Intersection B over probability of B. That's the definition of the conditional probability. E1 given intersection B from here would be probability of E1 times probability of B given E1 over probability of B. And you can find probability of B from here also, if you want, from 3 places. Probability of E1 times probability of B given E1 plus probability of E2 times probability of B given E2 plus probability of E3 times probability of B given E3. All of this. This is probability of B. So probability of E1 given B would be, let us find probability of B. It's 0.35 times 0.25 plus 0.25 times 0.15 plus 0.4 times 0.6. And E1 intersection B would be one of these 3. Okay, it is here the first one, which is 0.35 times 0.25. Here E2 given B, the same. It would be probability of B below here. So all these 3. And in the numerator, you will have E2 intersection B, which is the second one. The second one here, this one. 0.25 times 0.15. Also, probability of E3 given B, this would be over probability of B, which is the same in the three cases, but now we have 0.4 times 0.6 in the numerator. Notice that remark, if you add probability of E1 given B plus probability of E2 given B plus probability of E3 given B, the answer would be 1. So this is to check your answer. The sum of these three probabilities must be 1. Let us solve another question about Bayes theorem. A hair salon caters to both men and women. In addition to hairstyles, the salon provides back and shoulder massages. In the past, 42% of men have requested massage and 61% of women have requested a massage. The salon's customers are 48.2% men and 51.8% women. So the customers are divided into two, men or women. Probability of men, 48.2%, so 0.482. Probability of women, 5.518. So these are the customers of the salon, either men or women. Okay. Now the total, if you add these two probabilities, you should get 1. Now there is an event he is talking about, which is back and shoulder massages. Let me call it G massages or G complements, no massage. G massages, no massages. So some of men will ask massages. So what is the probability of asking a massage from men? Okay, 42% of men have requested massage. So if he is a man, what is the probability of requesting a massage? 0.42. So if 0.42 requesting a massage, 0.58 will not request a massage. Women requesting massage, 61% of women requests massage. So 0.39 will not request a massage. We have this tree diagram. If a customer arrives for a hair appointment, what is the probability that the customer is a woman who will also, so women and, let me write, and massage. So what is the probability that the customer is a woman who will also request a massage? So women and massage. So women and massage, we can find and from here. It is probability, it should be a probability of M times probability of G given M, okay, which is 0.482 times 0.42. So this is probability of women and G. Calculate the probability a customer will ask for a massage. So this is probability of G asking for a massage. He could be a man or a woman. So asking for a massage, we multiply 0.42 times 0.482 plus 0.61 times 0.518. Here asking the massage from men, here asking massage from women. So this is the total probability of asking for a massage. Given that the customer does ask for a massage, so we know that he asked for a massage. What is the probability that the customer is a man? Given that. So given that, this is a conditional probability. So we need to divide by probability of G, which is in part B, this probability. And we need here M intersection G. This is M intersection G. Sorry, this is women and G. So it should be probability of women times G given women. So it should be 0.518 times 0.61. Now 0.42 times 0.4, this is 0.42 times 0.482. This is the probability of M and G. M and G. Okay, some more questions. A regional bank has two branches, B1 and B2, in an urban areas. 80% of the total customers of the bank use branch B1. So we have B1, branch B1, and branch B2. 80% of the customers use branch B1. So probability that the customer will use branch B1 is 0.8. So probability of using branch 2 would be 0.2. Studies show that 40% of branch B1 customers are female. So branch B1 has females and males here, females and males. 40% of branch B1 is females. What is the probability of a customer being a female given that he came to branch 1? 0.4. So 0.6 would be the other probability. 70% of branch B2 are females, so probability of a female given branch 2 is 0.7. So this would be 0.3. Now, what is the question? Suppose a female customer is interviewed. So I know that the customer is a female. What is the probability that she uses branch B2? So he is asking for probability of B2 given F. By definition, this is probability of female, and here probability of B2 intersection F. I can find that from the tree diagram easily. B2 intersection F is 0.2 times 0.7. Probability of F is 0.8 times 0.4 plus probability 0.2 times 0.7. So this is probability of F in general, and this is B2 give intersection F. Here you have B2 intersection F, here you have B1 intersection F, and you will find the probability. The last exercise in the section, a drilling company has estimated 40% chance of striking oil for their new well. A detailed test. So we either strike, the company will either strike oil or not. Okay. It strike oil, let us say oil, strike S or not. Probability of striking oil is 0.4. Not, of course, would be 0.6. Okay. A detailed test has been scheduled for more information. Historically, 60% of successfully wells have had a positive test. So let us say positive plus, or let me write, let me call it T, okay, test, T and F, T and F, T true and false, okay. This is positive and this is negative. So successfully, if the well is successful, 0.4, 0.6 had a positive report. So 0.4 of the successful has full, not a positive report, negative reports. 20% of unsuccessful wells have had a positive test. So 0.8 will have a negative test. What is the question? Historically 60% and 20%. There is no question. The question is missing, is not written. So let me continue the question from myself. Okay. Let me say if a report, or if a positive test report is given, what is the probability that the oil strikes. So the will is successful, oil strikes. So what is this? How to answer this question? Now we know that a positive test. So T, we know that a positive test is given. So it had a positive test. What is the probability of successful? That's the question. What's the probability that oil strikes or successful? So this would be equal to probability of S intersection T over probability of T. Probability of T you can find by multiplying 0.4 times 0.6 plus 0.6 times 0.2. And probability of S intersection T is 0.4 times 0.6. And you find the answer. This is the last point in this section. I stop here and I open the floor for questions.